Good morning, everyone. Welcome to the webinar on guidelines for effective data visualization. My name is Ksenia Bocharova from Yaxis International and facilitating this webinar, which is part of the training workshop and webinar program of the Publications Office of the European Union, linked to the EU DataViz conference, which takes place this year in November in Luxembourg. More details will follow at the end of the webinar. This session will be recorded in order to provide you with the slides recording and the link to the survey at the end of the course. I'm here with the speaker and now I give him the word.
Hello, good morning, good afternoon for people in other time zones. My name is Maarten Lambrechts and I'll be your trainer for today. Today we're going to discuss guidelines for effective data visualization, and so we will be talking about data quality for data visualization. We will see a lot of pitfalls in data visualization design, and I'll also show you some tools that can help you avoid the pitfalls of data visualization. But first I want to talk a little bit about why we are visualizing data, and also why it is a good idea to make visualizations or publish visualizations instead of tables like this. So this is a table showing you the imports and exports between the UK and Norway and Denmark from the year 1700 to the year 1780. And this was a data set that was published in a book in 1786 by a Scottish engineer named William Playfair. He noticed that publishing tables was actually not very effective for communicating numbers. If you want to get some insights out of these numbers in this table, you have to compare a lot of numbers, and it's just not easy to understand what is going on here. So William Playfair saw that there was a need for something else, and he was actually the founding father of data visualization. Because in his book from 1786, he published this chart. So it's the same data, but now presented in a visual way instead of in a table. He invented the line chart, so this is one of the first line charts ever made. And William Playfair was very careful about the design of his chart. So on this chart, you can clearly see that the balance of trade switched from against England to in favor of England halfway through the 1750s. And you can also see that in the table, but you'll have to do a lot of mental work to get this information out of the data, while presented visually is much easier. What Playfair did in the design of this chart, for example, was putting the names of the lines directly on the chart. So the yellow line is labeled line of imports, and the red line is labeled line of exports. So he didn't use a separate legend like many charts that we see today have. And I think this is a very good design decision, and we will be coming back to this chart design element later in the webinar. So William Playfair was very careful in choosing the elements added to this chart, and I think, he thought a lot about this, and I think we should also do that. And so that is what we are going to discuss today, how you can make the design of your chart as effective as possible and as easy as possible to understand for readers. So what he actually did was making charts explain things to the readers of his book, to his audience. So this is one way you can use data visualization. It is to explain what is in your data to other people. You find something in the data and you want to convey this information to other people, and you can do that by using data visualization. So this is called explanatory data visualization, and this is also what we will be focusing on today. There is also another goal or another goal that you can use data visualization for, and this is exploratory data visualization, and this is where you use data visualization to get a sense of what is in your data, to get familiar with your data and try to find the information contained in the data. But this is not really what we will be focusing on, although I will mention it during the session later on as well. So during this webinar, I'm going to focus on practical guidelines. So I want to give you some guidelines that you can apply directly in your work whenever you're making visualizations. And one way of doing that is looking at some common pitfalls in data visualization, some errors that get made on a regular basis. And I think by showing you these examples, you can get a sense of things to avoid when you're making visualizations. So that will be a big part of the session. And after that, I will also show you some handy tools that can help you evaluate the design of your visualization, improve the design of your visualization. I'll also show you a tool that can help you to choose the right chart type, because this is one of the most common questions in data visualization. What chart type should I use for my data? So I'll show you a tool for that as well. And then in the end, I'm also giving you, or I'll also show you a tool with a lot of links to help you make different kinds of visualizations with the tools that you are already familiar with. So this is a tool that can help you choose a tool in a way. But before that, I think we need to discuss one important issue that is often overlooked in data visualization, and this is data quality. I want to just quickly run you through common mistakes in data quality or common errors in data that can lead to visualizations that are not really showing the truth or showing the data as it was meant when it was collected. Data visualization is a process that to which the concept of garbage in, garbage out really applies to. So if you have issues with your data, then it's guaranteed that your output, your visualization will also have issues. So I think it's worthwhile discussing data quality a little bit before we start looking at actual visualizations. So the first guideline I could give you is to take a look at the metadata. Whenever organizations publish data, they usually also publish metadata, data describing properties of the data that is published. And whenever you read the metadata, then only then you can get a sense of things like how was this data collected, because data coming from a government database is very different than data collected with an, for example. So make sure you understand how data was collected. You should also be conscious about the used definitions. If you talk about things like unemployment rates, then you need to know that many different organizations use different definitions of what an employment rate is. Make sure that you understand really well the definitions that are used in the data set. And many metadata also describe limitations of the data, and they will state something like, well, this data set is not really comparable to the previous data set because there was a change in methodology or some things. So check the limitations also in the metadata. Whenever you open a new data set for the first time, then I think one best practice, so to speak, is to do some basic checks. And I call it data profiling here. It's just inspecting your data to see if there is anything suspicious or missing in your data set. And this is more part of the exploratory data analysis. So this comes before making visualizations to explain things to others. And in the data profiling, what you should check is if there are any missing values in your data. You should also know how missing values are encoded. Maybe there is a dash in your data, or it can be that missing values are indicated by a 0. So you need to know how missing values are handled in the data, and only then you can decide to leave out some of the records in your dataset, for example. Checking for duplicates is also very useful, and then you need to know if duplicates are as expected, then you should be able to handle them, leave them out, or keep them. Sometimes duplicates are also useful information. One of the biggest problems that you can encounter in data sets is standardized data, and this often happens when humans enter data manually into a data set. If you take, for example, a data set where people have to indicate their country of residence, and you have people from Great Britain, people can make spelling mistakes. They can just put GB, for example. They can use abbreviations with dots, without dots, with capitals, without capitals. So you need to check for these kind of unstandardized fields in your data and try to come up with strategies to standardize the data that you're working with. And lastly, I think it's important to check for suspicious values, values that fall outside of what you would expect in the data, and also outliers, the very high or very low values, or the data points that do not follow the general trend of other data points in your data. So I think those three things, oh, I'm sorry, there's one more, source of error in the data. And these are different kinds of errors. These can be transformation errors whenever you do some intermediary calculations. It might be that you made a mistake, so it's always a good idea to check what you've calculated and maybe try to come to the same calculation result with a different route to see that what you came up with is in line with the alternative way of calculating things. Data type mismatch happens, for example, when you have dates in your data, but the software that you're working with does not recognize the date format, and it's considering the elements in your data to be strings, just characters. So this will also lead to visualizations that do not really reflect what is in the data, and we will see an example of that in a minute. Then definition mismatch has to do with the definitions. It might be that one data set is using a different definition of what an unemployment rate is than another data set. And then, of course, you cannot really compare the two unemployment rates and put them on the same chart because they were measured in different ways. When it comes to data quality, read the metadata, inspect your data before doing anything else, do some data profiling, and then also check for the errors you can see at screen right now. So after you have identified and resolved the data quality issues, what you then can do is start visualizing. And this is where we are going to look at some common pitfalls in data visualization design. So I'll be showing you lots of examples, and I will try to explain how people fell into these pitfalls and what you can do to overcome these pitfalls. So the first example I wanted to show you, this is in Dutch. My apologies, this is a chart published by a political party here in my region of Flanders. And they wanted to show that people in our region are retiring, or in our country are retiring at a quite young age compared to other countries. So what you see here is the effective retirement age for different countries, and on the left you have Iceland, which has the highest age at which people retire, and the bar marked in yellow is the bar for Belgium, and you can see that the retirement age for Belgians is a lot less than what it is in Iceland. But when the people making these charts designed it, they made one decision that I'm not really comfortable with, and that is not starting the y-axis at 0. As you can see, the y-axis starts at 55, so that means that a big part of the bars was cut off. In doing so, the proportions in the chart are distorted. If you compare the bar for Belgium, it looks like it could fit 3 or 4 times into the bar of Iceland, the highest bar. In reality, the difference is, of course, a lot less. What I would say here as a guideline is to never cut bars. And you can say, well, people can read the values. There is some annotation on the chart. People can look at the axis. But you have to know that a lot of this visual information in data visualization is processed by people automatically. So first impression, they will compare the length of the bars and they will already get a sense of a really big difference, while in reality the difference is a lot less. Then of course the question is what to do, what can you do to avoid this pitfall, because in a lot of cases small differences can be significant. My advice there would be to show the deviation from the average, for example. Then you would see that some countries are above average, some countries are below average. Or you can show a deviation from any other meaningful value with bars. Another strategy to overcome this problem is by using another visualization type. You could use dots instead of bars, for example, and then you will suffer a little bit less from the problem that people will start comparing lengths, because with dots, not starting the y-axis at 0 is a little bit less problematic. There's something else going on in this chart that I would like to talk to you about. If you want to read all the labels on the chart, then you have to turn your head a little bit, because the labels, the country labels on the chart, they run vertically instead of horizontally. So that's why I call these kind of charts stiff neck charts, because it will give readers some issues with their necks if they read too much of these charts. And actually this is quite easy to solve. If you would rotate the chart 90 degrees, then all the labels would run nicely horizontal, will be very easy to read. So the second guideline that I would like to give you in avoiding data visualization pitfalls is to make text run horizontally as much as possible. If you want effective data visualization, then you need to make the life of the reader, of the viewer, as easy as possible. And vertical text is just harder to read than horizontal text. So try to make the text run horizontally as much as possible. Pitfall, and I briefly touched already on this topic. Whenever you have a data set and the date column in your data is not recognized correctly by the software you use to make visualizations, then you will end up with charts like this. This is a chart or a group of charts showing you the poverty rates in different regions in the world through time. But if you pay attention to the x-axis, you'll notice that the first data point is for 1990, the second one is 1999, then the third one is 2012, and the last one is 2015. So you have a period of 9 years between the first and the second data point. Then you have 13 years between the second and the third, and then only 3 years for the last time interval, which means that the intervals between the data points is not regular, but they are visualized as if they were. And this leads to a sudden drop in the it looks like that poverty rates suddenly dropped quite steeply between 1999 and 2012. But this is actually not the case. This is an artifact. This is a result of the visualization not respecting the intervals in time. If you would correct this chart and respect the time intervals between the data points, the chart would look like this. And you can see that on this chart, the sudden drop in the poverty rates is not visible at all. And we are just seeing a steady decrease of the poverty rate. And so one thing to remember from this chart is that you shouldn't cut time access. And it can be that this is done not deliberately. If you have a date column which is not recognized as being a date, then it will lead to charts that show you trends that are in reality not there. But sometimes people will do it deliberately, and this will also distort the trends that are in the data. So just as you shouldn't cut bars, you also shouldn't cut time. So this is another guideline that I would like to give you. The next guideline or pitfall has to do with the legend that many software puts whenever you generate a chart. And I already showed you the chart by William Playfair, where he put the labels of the lines directly on the chart. This is an example of a chart where the labels are put in a separate legend. And this can lead to some problems. For example, for people who suffer from some kind of color blindness. And also, if you print the chart in black and white, it will look like this, and it will be very hard for people to identify on this chart, for example, the line representing medical school and the line representing law school, because their colors are now very similar. So it's not that hard to overcome this problem. What you can do is just leave out the legend entirely and put the names or the name of the categories of the time series directly on the chart. And then if you want to improve this even better, you can repeat the colors. And now very few people will have trouble identifying each line. And whenever the chart is printed in black and white, it will also still be legible without any problems. So whenever you can, try to label things on your chart directly and try to avoid separate legends, because separate legends will oblige the reader to skim back and forth between the chart and the labels in the legend. So what you should try to avoid is that the reader is losing his or her focus by just constantly having to change the legend and the chart itself. And so what you can do is label things directly. This will usually involve some manual label placement, and sometimes you also run into trouble when values are close together. But if you can, I would advise you to try this technique of direct labeling. The next pitfall is about color, and color is a very big topic, obviously, in data visualization. But what I would like to advise you is to use color deliberately. So think about the colors that you're going to use, and not just use the default that the software you're using is giving you, because usually there's room for improvement in the color schemes that you're using. I'm showing you here the color scheme used by Microsoft Excel from some versions before today's version. And yeah, it's very obvious that this is not an optimal color scheme. Sometimes you also have very obvious choices for color. For example, if you have a chart about political parties, then of course it's advisable to use the party colors to identify each party on the chart. In many ways, you also want to stress something on the chart, so you can give the things that you want to stress a brighter color and use muted colors for the other elements on your chart. So try to go beyond the defaults. You could also consider, for example, using the colors of your organization that you're working for. Use the branding colors, and this will usually also give nice results. Then it's also important to use color sparingly, which means that you shouldn't give everything on your chart bright colors, because then the reader will not know what to look at first. If everything is brightly colored, then nothing stands out. So you should focus the attention of the reader to the most important elements on the chart and use color sparingly. So in this example, a very minimalistic chart, you can see that everything is black and white except for 2 data points which are labeled in red, and for the reader it's very obvious where he or she needs to look. So use color, but use it sparingly and use it to focus the attention of the reader. Related to this is that you should use color hierarchically. It's a bit of the same concept. Make things that are the most important stand out, and make things that are just used for context reside to the background by using some muted colors. Then there is the concept of chart junk. Chart junk is a term invented by one of the great names in data visualization. His name is Edward Tufte, and I can highly recommend his books. They are full of great examples and explanations about how to design data visualizations. And what Tufte is saying is that you should avoid chart junk. And what you are looking at is one of the examples that Tufte uses in his books. And he says that this is a bad chart because it has a lot of chart junk. There are a lot of things that draw away the attention of the reader from the data. And it's actually not so easy to read data from this chart. You have the monster, you have the curved grid lines, the curved axis. So this is not a really very effective chart when it comes to reading values. And so that is why Tufte says that you should avoid chart junk. But then, of course, if you follow this minimalistical philosophy about data visualization, what you will end up with would be something like this. So this is the same chart, but now all the chart junk is removed, and this is a very effective chart. You can read the values, you can compare the values, but it's also a very boring chart. So whenever you design visualization, I think you are somewhere in between those two kind of charts. On the one hand, you have charts which have a lot of color, maybe with some illustration added, which are meant to draw the attention of the reader to the chart. On the other hand, and you will have charts like this, which are very minimalistic, dry, and some people might say boring, but they are also very effective. So depending on the audience, depending on the topic, I think you should choose where you should be in this continuum between the chart with a lot of illustrations and the chart which are maybe boring but very effective. So be aware about chart junk. If there are added elements to the chart that don't have anything to do with the data, know that those elements will draw away the attention of your reader away from the data and will make it harder for the reader to interpret the data effectively. I have a nice illustration, a little animation showing you this concept of it's also an illustration of what he calls the data ink ratio. In DataViz philosophy, you have to maximize the data to ink ratio, so you have to show as much data as possible with as little ink or pixels possible. In the animation, I'll show you how we go from this chart, remove all the chart chunk and optimize the data to ink ratio, and we'll end up with a chart that's much more effective. So it's called Remove to Improve, an animation made by Dark Horse Analytics. And as you'll notice, the only thing that happens during the animation is things get removed, maybe sometimes moved to a different place on the chart, but it's almost always just removing things and putting things to the background. And as you'll notice, we'll end up with something that's very minimalistic, but quite effective. It's the final result is a chart that people will have no trouble with interpreting, reading the values and comparing the values. As you'll notice in the animation, we are also already removing the separate legend. So this is one of the guidelines that we already have discussed before. So it's a nice summary of those two guidelines of maximizing data to ink, remove chart chunk, and remove the separate legend. There is also a pie chart edition of this this animation. I'll also show it to you, and it's already hinting at some of the other guidelines that we'll see, and also hinting to the tool that we're going to see to select the most appropriate chart type. So again, it's removing things, removing the 3D, removing colors, and right now it's even removing the pie altogether. And the reason for this is that bar charts are more effective than pie charts if you want your reader to really read the values in the visualization. So you have to be conscious that whenever you use pie charts, then people will not be able to really see small differences between the categories in your visualization. If you want them to see those kind of small changes, then a bar chart is more appropriate than a pie chart. Okay. Then what is often overlooked in data visualization is the aspect ratio of a visualization, or the ratio between the width and the height of a visualization, because this will determine a lot of how a chart looks like and what people will be able to see in the visualization. So here's an example of a chart that is very wide but not very high, and it's actually the y-axis on this chart that is encoding the data that the author of the chart wanted to show. And as you can see, there is not a lot of variation, which means that we basically have almost flat, and people will not be able to see the variation within the data. So I think this chart could be made better by making it narrower and probably also higher, and only then people will be able to see what is going on in the data. So make sure that the axes that you're using to encode the data have enough space, and think about whether a chart should be higher or maybe narrower, because this will determine what people will be able to get out of a chart. So think about width and height, because they are very important to determine the aspect of a chart. Then I would like to discuss the scaling of circles. This is a visualization. Well, it's a very simple one. You have two circles encoding just two numbers, 37.7% and 69.2%. And when I saw this chart or visualization, I had the sense that something was not really right. If the proportions of the circles would be correct, then the blue circle would fit not even twice in the bigger circle. So I took the two circles and then put them on top of each other, and as you can see, the blue circle fits 3 times in the red circle. So the proportions, the areas of the circles are not proportional to the values that are shown here. And the reason for that is that if you scale circles by the radius, then you're actually squaring the area of the circle. So what happened here was that the author of this chart, of this visualization, mapped the data to the radius of the circle, but the area of the circle is determined by the formula pi times r squared. So you are squaring the differences between the two values that you shown here. So make sure that if you use the area of circles to represent data, that you take the root of the numbers first before mapping it to the radius of the circle. And if you take the radius, then this is actually these are the correct proportions between the two numbers that were shown. So a bar chart would have been correct in this case by mapping the data to the radius of the circle. The small or the difference between the numbers was actually squared and then blown up, and in the end the area of the circles was not proportional anymore to the real data. Then we have another technique that is often used and that can be misused on charts like this. So here we have a chart showing the spending on science and space and technology in the United States. And it looks like it's very clearly correlated with suicides by hanging, strangulation, and suffocation. And the author of the chart was able to suggest this correlation by using a technique, and the technique is called a secondary y-axis. So if you look carefully, you can see that this chart is actually using 2 y-axes. You have one in red on the left for the red line, and you have one on the right in black for the black line. And whenever you use a secondary y-axis as a chart author, you can decide for yourself how you are going to stretch or how you are going to squeeze the second y-axis. And in this case, the author of the chart chose the right axis in a way that the 2 time series would really look very similar. But in reality, the author of the chart was really free to choose the y-axis in the way he or she just wanted. So these charts come from a book called Spurious Correlation, and there's another example here. It's not updating anymore. I'm sorry, the stream is not updating my slides. I'm going to try again. No, it's stuck, like it's stuck. Okay. So I just reshare my screen. So how do I do that? I'm I'm trying to reshare my screen. Okay, it looks like we've solved the issue here. So as I was saying, whenever you use a secondary y-axis, as an author, you just have complete freedom on how to squeeze or stretch things, which could lead to charts like this, which suggest a clear correlation, while in reality this might not really be the case. So try to avoid secondary y-axis. If you want to show two things on this, just make two different charts and put them next to each other instead of trying to put them on the same chart. So with charts you can suggest correlation, and one of the chart types that is used a lot for showing correlations are scatter plots. And this is an example of a scatter plot. So on the y-axis here you have the chocolate consumption in kilograms per capita per year for different countries, and on the y-axis you have the number of Nobel Prizes won per 10 million inhabitants. And as you can see, there is a very clear correlation. If you have countries where the chocolate consumption is high, then you notice that those countries also win a lot of Nobel Prizes. But of course, you cannot say that we should just stimulate the chocolate consumption in countries so they will win more Nobel Prizes. What's happening here is that there is a third variable, namely economic development, that is steering those two variables. So whenever countries get richer, people have more money to buy luxury goods like chocolate, and countries also have more money to invest in education, which then will lead to winning more Nobel Peace Prize or Nobel Prizes. So you can see that the countries on the top right are the countries that are typically the ones leading the rankings in economic development. So those are the richer countries, and they also eat a lot of chocolate because of this. So whenever you use scatter plots, be careful to not suggest causation when only correlation. So correlation is not causation. Whenever there is correlation, this does not necessarily mean that one of the variables shown is the next pitfall I'm going to illustrate by showing you this chart. This is Steve Jobs during one of his famous keynotes, and in this particular keynote he was highlighting the market share of the Apple iPhone. And this is represented by the green area on the chart. But if you look closely at the values shown on this chart, you can see that the green area represents 19.5%, while the purple area is smaller but represents a higher value. So the designers of the chart actually did was tilting this chart in the third dimension, and this makes the areas on the top of the chart look smaller and the ones at the bottom look bigger. This shows you the same chart, but now also an alternative version where the Apple iPhone market share is put in the back. And you can see that there's a very big difference in the green areas between those two charts. So whenever you put charts in the third dimension, you are distorting proportions. And of course, again, you can say all the parts of the pie are labeled, but still it will be a misleading message. So there are other issues with representing the objects on a 2D surface. The guideline here would be to try to avoid these representation in the third dimension in data visualization. The next pitfall has to do with ordering. So what you're looking at is a chart showing you the obesity rate by country in the EU. And as you can see, the countries are ordered according to, well, it's not really alphabetical order, it's the order used by the EU for showing you a list of countries. And as a reader, it's not very hard to extract meaningful information out of this chart. You might identify the country with the highest value there, maybe also the country with the lowest value, but in between things get really hard to compare. So another version of this chart sorts the data on the values, and now this is a chart that is much it's much more enjoyable to look at. Things don't jump up and down anymore. Countries are clearly ranked, so you can see immediately what the top 5 countries for obesity rates is, and also the countries at the bottom. So whenever you want people to see things in the data, then it's usually a good idea to also sort things on the data. The chart on the left can be helpful if you want people to quickly look up the value for their own country. This is actually a bit harder using the chart on the right. But if you are explaining something about the data, then probably the chart on the right with the ordered data is much more appropriate. Then a word on chart titles. So what you see here is a map of European countries colored by their level of economic development or by their gross domestic product. And very often the title of maps like this will have a generic title, like in this case, countries by GDP. While in the surrounding text, you might explain something about the countries that have the highest GDP, what the reason is for that, for example. Then, of course, it's more appropriate to change the title of the chart, or in this case, the map, to something like this, where you can see now immediately as a reader what you should focus on while looking at the map. So the title now is Ireland, Netherlands and Austria are the richest EU countries, and for the reader it's immediately clear what he or she should take away from this map. So don't use generic titles, and try to already tell the story of your charts in the title of the visualization. Then this chart, we've already discussed the secondary y-axis. This chart is also using a secondary y-axis, but there is a lot more going on in this chart. So you have bars, you have lines, you have call-outs, you have other kinds of annotations. So in this chart, a lot of things are going on at the same time, and as a reader you will just be overwhelmed unless you are very familiar with the topic, or if this is a chart that gets periodically updated and you're familiar with it, you will not be able to extract useful information out of this. This is just a chart that is too busy, and it's a bit like the chart in this cartoon. This man there is showing one of those very busy charts, and he's just saying, well, I'm just going to have you look at this, and you can let the information sink in, but of course there's no real information to get out of this chart. This is just a busy chart, and as a reader you're just lost about why this chart is showing to you and what you should take out of it. The guideline here would be to only use one chart for one message and not try to put multiple messages into a single chart, because this will be overwhelming for readers. And one alternative technique that you could use to do just that is to use small multiples. So small multiples, multiple small copies of the same chart, and this will avoid having overcrowded charts. And if you want, you can say something about every line, as in this case, you have lines representing different countries. And this is very not overwhelming at all. If you would put all these lines onto a single chart, then it will be a lot less readable and effective. Then some words on maps, because maps are obviously also data visualizations, and also a lot of things can go wrong when mapping data. So what you see here is a map of the presidential election results of 2016. It's on the way to be hung on the walls of the White House. And it's a map that President Trump likes a lot because there's a lot of red, the color representing his Republican Party on this map. But this map is actually ignoring one important point about the election results, mainly that a lot of the red area on the map represents areas where not a lot of people are living. So you have a lot of Democratic voters, blue voters in the big cities on the East and West Coast. And the way they are represented on this map actually underrepresents them. So another way of showing the same data would be something like this, where you use circles, and the circles are scaled by the population. And now this map gives a much more nuanced image of the election results. And so whenever you represent things on maps, it's a good idea to scale the numbers. So here we are scaling for population, and this was not really taken into account in the first example of this map. And it's actually a pitfall that's quite common. So this is a map I took from the Twitter feed by Eurostat, and they are showing here a map of how many percentage is of the scientists and engineers living in the EU. And you can see there the ranking. You have the UK first, then Germany, France, Spain, and Poland, and they are also represented on the map. But those are the countries that have the highest population in the EU, and it's kind of logical that bigger countries have more scientists and engineers because they simply have more people. So on this map, the numbers are also not scaled to the population. And I think it would be a little bit more interesting if the numbers would show the share of engineers and scientists within the country's population and not in the total population of the EU. And so whenever you represent numbers on the map, you probably have to scale for population to show anything meaningful. Then the last pitfall, I think this is about map projections. So what you are looking at is a map produced by The Economist, and they wanted to show the range of different kinds of rockets or missiles that North Korea has. And they took this map and draw and criticized a lot by photographers because drawing circles on a map, well, those circles will not represent circles on the globe. And so they had to correction, and the actual map should look something like this. So be conscious that whenever you see a map, you are looking at the 2D representation of something that is three-dimensional, and there will always be distortions. And this is especially the case when you're looking at maps that have the Mercator projection. So be aware that straight lines are not straight lines in reality, and circles are also not real circles on the globe if you draw them on the map. So those are a list of the most pitfalls when it comes to data visualization design. I think what I want to show you next is a nice summary of this, and it will even go beyond what we have already seen. So in the next part, I'm going to show you 3 tools, and I'm going to start with this tool called the Data Visualization Checklist. I think it's a very handy tool that you can use to evaluate your work in data visualization, and it's also just a nice list of guidelines to stick to whenever you make charts. So data visualization checklist was developed by Stephanie Evergreen and Emery, data visualization consultants from the US. And let me show you how it works. So you can see the URL at the top there. This will also be in the slides, which will run as well. And there are actually 2 versions of. Hang on. Now I need to. No, I need to share my screen instead of my slides.
Yes.
Okay, here we go. There's a dedicated page on Stephanie Evergreen's website where you have an interactive version of the guidelines. So what you can do is you can upload a visualization you made, and it will go through a set of 24 guidelines, and that will ask you questions whether or not your visualization respects that specific guideline. But I'm going to show you the PDF version, which is also hosted on the same website. It's the same content, the same list of guidelines. And the way this works is that you have all these guidelines listed here. They are all organized in different chapters. So the first one is about the use of text on your chart. Then there's a set of guidelines about the arrangement. I'll pick some of the guidelines later on to illustrate how these guidelines look like. So then you have guidelines on the use of color, and also guidelines on the use of lines, and then finally some overall guidelines. Let me pick the first guideline here. This is about titles, and the first guideline says that you should have a 6 to 12 word descriptive title, which is just left justified in the upper left corner. And then you have different options. If your visualization is following this guideline, you can give it 2 points. If it is somewhat following the guideline, you can give it 1 point. And if it's not following the guideline, you should give it 0 points. It might be that for some guidelines, well, they can be non-applicable to the chart that you made, and you can just leave out the guideline entirely. So with this guideline, you can rate your visualization on each point, and then in the end, you calculate the total score of your visualization. I think it's a nice tool to be aware of the things to consider in data visualization design. Of course, you are completely free to the guidelines, but the guidelines are a set of best practices, and whenever you deviate from the best practices, I think you have to have a valid reason to do so. It's a nice collection of best that you can use to make the design of your visualization a little bit better. I'll just pick one more example of the guidelines there. If we talking about arrangement, the first guideline there is that proportions should be accurate, which means that a viewer should be able to measure the length or area of the graph with a ruler and find that it matches the relationship in the underlying data. And then it also says that bar charts start axis at 0. So this is also one of the things that we have been discussing. So a lot of the pitfalls that we have discussed will also reappear in the DataViz checklist. So I really invite you to check for it online. If you Google data visualization checklist, you should be able to find it. You can download it, print it, or you can also use the interactive online hosted version if you like. So that is the first tool I wanted to show you. The second one is called the visual vocabulary, and the visual vocabulary is like a catalog or a collection of different chart types that you can use to choose an appropriate chart type, or that can give you inspiration for other kinds of charts whenever you are making visualizations. So this was developed by the Financial Times, and let me also show you how this works. So this is also freely available online. You can download it and print it. You will probably have to print it in a big format because the font size is quite small and the collection of charts is quite big. But there is also an online version, and I think I can better use this one to show you how it works. The collection of charts in the visual vocabulary are organized in, I think there are 9 different categories. And I like that tool because it asks you first what you want to show in your data. So it's not asking you how your data looks like, but it really makes you think first, what do you want to show to the reader? So this actually refers back to the explanatory data visualization. You found something in the data, you want to communicate it to other people. So what is it that you would like to focus on when you are telling a story with data to your readers? And so you have these different categories ranging from deviation over change over time, all the way to spatial information, spatial data, and flow. Now, suppose that you want to show readers some things that are changing over time, then you can click this category over here, and then the vocabulary will show you all the different chart types that you can use to show change over time. So you get these little icons or mini versions of the chart with very limited explanation. It will sometimes indicate for what cases the chart is very good to use and in what cases you should not use them. I think it's an excellent way of give you an overview of what you could use as a chart type. And of course, when we talk about change over time, you have your standard line chart there, but there are many other different techniques. So it can also give you some inspiration when you are getting bored of lines, or when you think other chart types would be more appropriate. The visual vocabulary can give you some inspiration. The last tool I wanted to show you is called the Chartmaker Directory, and this was developed by Andy Kirk, the author of the visualizingdata.com website. Andy is a consultant, data visualization consultant from the UK, and one of the questions that he got a lot was, well, you showed me some interesting charts, but I cannot make them in the tools in the tool I use, or I don't know how to do it. How can I make this chart with the tool I'm familiar with, or where can I find a list of tools that can make this specific chart type? So the Chartmaker Directory is trying to come up with a solution to that question by giving the user of the tool a lot of links to tutorials and examples. And I think it's probably best to just show you how the Chartmaker Directory works. So the Chartmaker Directory is actually a big matrix. I hope you can still see my screen here now. Okay. So the chart maker directory is a big matrix where each line represents one specific chart type. So you can see that we have bar chart, we have clustered bar charts, we have a bullet chart, other kinds of charts. And each column is a tool that you can use to make visualization. And whenever the two, in each cell of the matrix, you get these dots, and the dots are links to examples of this specific chart made with that specific tool. So maybe we go to the column of Microsoft Excel. You can see there are a lot of dots there, so you have a lot of examples. And if we just click one of these, so this is bullet chart made in Excel. It will open the link, and you should be able to find either an example or a real tutorial, as is in this case, where someone explains you how the chart works and how you can make it in Excel. The chart maker directory has a lot of different chart types, as you can see. You can filter here by this is a search field you can use to find a specific chart type, and then you can also just browse to the tools you're familiar with to find a tutorial about how to make that chart with the tool you're familiar with. So I think together with the visual vocabulary, where you will find a catalog of different chart types, the chart maker directory will help you make all these different kinds of charts in the tools you are using. So with that, I think we have come to the end of this webinar. I would like to thank you for attending. But before we leave you, I would like to quickly mention two other webinars that are coming up. The first one on the 26th of September about telling your story through data visualization, and another one 2 weeks later on the 10th of October, where I will be sharing a lot of non-standard visualizations, so charts that go beyond bar charts and line charts. So you can also sign up for these. And then finally, later this year on the 12th of November, we'll have the EU DataViz conference in Luxembourg, focused on the public sector, data visualization in the public sector. And so if you have any interest in that topic, I can highly recommend attending this conference as well. So
with this, we would like to thank everyone for participating in this webinar. We are warmly welcoming you to continue the sessions with us. The recording slides and the link to the survey will be shared with you soon. And we would like to encourage you to check EU Open Data Portal website for the slides from the sessions that have been already delivered, where you can find plenty of information on different tools and different techniques on data visualization. Thank you very much, everyone, and we wish you a nice day.